Uh, okay, so let's start with this week's tutorial. I hope you guys have got the tutorial questions with you, right? Uh, Guys, you can hear me right now? Okay, great. I was muted all this while. Okay, so let's start, right? So all of you must be having the tutorial questions, right? Like last week, you guys will actually need to submit the tutorial solution in the Dropbox provided on your Moodle shell, right? So while I'm discussing the solutions, please try to take the screenshots of it, right? If not, I'll give you time to take the screenshot at the end, right? So there's only one question to discuss. Just in case if it crosses, I mean, while I'm discussing, if this crosses the time limit of 40 minutes, right? And this particular session ends, please rejoin using the same link, right? But I don't think the tutorial session will last that long, but just in case, right? If the tutorial session ends before that, please rejoin again using the same link, right? Okay, so let's start. So there's only one question. So question number one. So a figure of automatic fruit counting system is given over here, right? To develop such system, we use big microcontroller, and the sensor, display unit, and motor are used as well, right? So this is the system that we are talking about. So this is a system that automatically counts the number of fruit bags that passes by, right? So A is the conveyor belt motor, B is the proximity sensor, while C is the display, the 7-second display, right? So there are some specifications given over here regarding this particular system. So it says to develop the full application with hardware and software logic, we assume that a suitable driver IC for DC motor is available to drive at normal speed, right? So one, draw primary connection diagram for the above system such that the following are incorporated. So A, turn on and off the DC motor for the conveyor belt through pick pins. B, detect each fruit passing through the proximity sensor. Use external interrupt enable to detect the pulse from the sensor. Increment the counter for each pulse receiving from the sensor output. Consider high to low logic for detecting input pulse, right? Display the count value on the 7-segment display as soon as the bag is detected. The display number shows the total number of bags passed during the operation. They use single port for 3-module display, right? So basically, these are the specifications. It just says to turn on and off the motor pins using the pick pins, and then using the proximity sensor, we are going to count or detect the number of bags that passes by, right? So as one bag passes, we need to increment the count, right? So at the end, whatever value is displayed by the 7-segment display, it is basically the total number of bags that has passed through the proximity sensor. So that is what needs to be done, right? So we need to write a pick program that enables all this operation. So the first thing is to draw the connection diagram as it says. So the connection diagram will be something like this, right? The diagram that is given here. Please do take the screenshots of it while I'm discussing right now. Like I said, there's 3 elements that needs to be interfaced with the microcontroller in this case, right? That is the proximity sensor, the 7-segment display, and the motor, right? So the proximity sensor, the 7-segment display, and the motor. So like we discussed last week, whenever we have an peripheral or a device connected to the microcontroller that draws more than the capability of the microcontroller, right? The current source capability of the microcontroller. If there's such kind of peripherals or devices that needs to be interfaced with the microcontroller, then we'll need to use a relay or a driver, right? So in this particular case, the microcontroller does draw more than the amount of current the microcontroller can withstand, as well as the amount of current that it can source, right? So we'll need to interface it using a driver circuit, right? In order to protect the microcontroller. So that is why we are using a driver circuit. This is a driver circuit that is used to interface the motor, right? So that is interfaced to, let's say, we are assuming that is connected to pins C0 and C1, while the proximity sensor is connected to pin B0, right? And as it said in the description over here, we need to use we need to use a single port for the 3-module display, right? We have already worked with the 7-segment display in our labs, so we all understand that we'll need 3 pins to turn the LEDs on and off, while there will be a set of ports that will be passing the data to that particular to the particular 7-segment display we are referring to, right? So we can assume that the data pins are pins D, right? All port D pins are the data pins for the particular 7-segment display, while A2, A1, and A0 are the turning on and off switches for the 7-segment displays, right? Also, the other thing is that when we are using a proximity sensor, we can also take it, or we can also count it as a switch, right? As the item passes by, it will give a high or low logic, isn't it? So that high and low logic is basically associated with to a switch as well, right? So we can consider that proximity sensor or a switch as a switch as well, right? We can model that in this particular case as a switch as well, right? So we'll model the proximity sensor as a switch in this particular case, right? And the rest of the definitions are given, like I said. The motors are interfaced to port C0 and C1. The proximity sensor is connected to port B0, while the data pins are connected to port D, while A0, A1, and A2 are the selection lines, right? So based on the requirement, we need to turn on this motor, right? So that the conveyor belt starts to operate. And as this bag passes through these conveyor belts, as it passes through the proximity sensor, we'll need to increment this count and display it on the 7-segment display. And since we are not controlling or dealing with the motor, we are just turning on and off. We are not dealing with the speed measurement of the microcontroller or anything like that. So basically, there's only one particular element or one particular device that is going to be using the external interrupt, that is the proximity sensor, right? So proximity sensor will be the only device that will be accounting for the external interrupt, while the motor operation could be just done by a simple high and low logic of the pins, right? By setting one of the pins high and one of the pins low of the motor, right? Like every device, there will be a positive and negative pin, right? So in this particular case, the motor will be also having a high and a low pin. So by setting those 2 pins high or low, we can turn on the motor. And the 7-segment display is just there. We don't need to do anything with that. So there is no external interrupt connected to the 7-segment display. So this proximity sensor is the only sensor that will be dealing with the external interrupt, right? And so based on this, still on this, so what we need to do, we need to initiate all these items, right? When we are writing the code, we need to define the pins, right? If we are defining, we need to define the pins of this interfacing devices, that is the motor, the proximity sensor, and the 7-segment display. We'll need to provide the hex code for the 7-segment display, right? All those are the definitions, right? And then what we need to do when we start writing the main code, we need to initiate, right? Or give an initial starting point of all these items. So just before we turn on the motor or we start counting, what we do is we need to set up this 7-segment display and the proximity sensor, right? So once these are ready, then only we can start the motor, because the motors will be having these bags, right? So that is why we need to initialize the proximity sensor and the 7-segment display before we go on to the motor and we turn on the motor, right? So that is our goal in this particular case. So when we are writing the program, so we'll start off with the definition. Like I said, we need to start off with the definition. So in this particular case, the definitions will be the duty cycle of the motor, right? That's one of the parameters that will be passed. And then we'll be using the 3 7-segment display, so that we'll need to have an array in order to store those values in that particular array for 7-segment display. The hex code of the 7-segment display as well, right? And then we start off the main program. Let's ignore this for a moment. This is just the external interrupt function, right? Usually, what we do is we can write this the external interrupt function after the program as well, but in that particular case, you'll need to just write the program definition or the function definition first, right? So let's avoid this at the moment. We'll go at the bottom and then we'll come back over here, right? So when we start with the main program, there is no need for the initialization of the 7-segment display. We have already given the initial the hex code. We have already defined it, so we don't have to worry about any other pin initialization over here. Then we move on to the proximity sensor, and then the motor. Motor will be the last thing that we want to turn on, right? Because if the motor starts and we haven't started the proximity sensor, the counting will be wrong, or it can give a wrong counting. Right? So keeping that in mind, we start off by initializing the proximity sensor, right? So in this particular case, we have to attach the external interrupt to the proximity sensor. So this is the code that we have to write for that particular in order to enable the external interrupt and attach it to the pin to which the proximity sensor is connected to, right? So we have been dealing with the external interrupt so far. So I believe all of you know how a external interrupt works by now, right? So basically, we need to clear the ports. We need to set which pins are the input pins and which pins are output pins. So in this particular case, we are considering the proximity sensor is being connected to pin B0. So pin B0 will be the input, right? We'll be taking the input from the proximity sensor. So that is what we are giving. And then we need to attach the pull-up or no, or disable any pull-up. So in this particular case, we are attaching, or we are interfacing the proximity sensor using a resistor, right? In this particular case, we are using an external interrupt, right? So an external pull-up is already attached. So we need to disable the internal pull-ups, right? So we disable all internal pull-ups, and then we need to define the external interrupt edge, right? So the definitions already even tells us that we need to define a program that uses a high to low logic, right? So we can go back over here and we can see that it already says we need to consider a high to low logic, right? So that is what we are doing in this over here as well, right? We're defining that particular edge in this particular case, and then we definitely need to enable the external interrupt and the global interrupt, right? Those two lines are there, right? So this basically defines the external interrupt part, right? So once we have done that, we go back to, there needs to be a program, the external interrupt program attached to this external part, right? There needs to be a function, the external interrupt function that is attached to this. So that will be this particular part, right? So whenever a bag passes the proximity sensor, the count increases, right? So in this particular case, we are attaching the external interrupt to the proximity sensor. So what happens when we go into the external interrupt loop? We need to count, right? So basically, when we are counting, we are increasing the count. So we have a variable count that needs to be increased, right? So what we do, we enter the external interrupt loop whenever there is interrupt, right? We need to define the function that will be a void function, right? Definitely, this is a void function that gives the ISR. I mean, it is named as int ISR, right? So we need to disable the global interrupt. We need to disable the global interrupt, and then we increase the count, right? Okay. And then you can enable the interrupt over here. Just after increasing the count, we can enable the interrupt just after this, right? But in this particular case, they haven't enabled the interrupt, right? Over here, they have chosen to put it at the end of the program. That's another way of doing it. So once you disable the interrupt, you increase the count, you can enable the interrupt over here, or you can leave it into the while loop, right? So we increase the count over here. Right, so that's regarding the external interrupt. Now we have done with the 7-segment display, we have done with the initialization of the external interrupt. The next thing is the motor. Motor starts the whole system, right? So once the motor starts, the counting also starts, right? As the BEX passes, the counting starts. So basically we are following a reserve logic, right? Reverse logic here, almost. So the next thing is to define the PD. I mean, when we are dealing with the motor, we need to, in order for the motor to operate, we need to control its speed, right? So that speed is basically controlled using the PWM, right? You guys might have learned this in your lectures as well. So when we are attaching the PWM, so the configuration goes by, we need to set up the timer that you are going to use for the PWM. So in this particular case, we are using timer 2. So we have to be really particular which pin we are selecting and which pin we are not selecting. This goes for your projects. We have to see which timer we are using and at which particular pin these particular timers are attached to, right? So we have to be really careful with that. So we need to set up the timer that is going to control the PWM, and then we need to set up the compare contrast. Compare. I think it's something. It's this CPP module. I forgot the name of this. Right? You just go back and just recap on this, right? I think it's compare capture or something. Compare capture PWM part, right? I think that's the name that is given to CPP. Compare capture PWM, right? So this is a module that controls the PWM, right? So we need to configure this CPP part, and then we need to set the PWM. In this particular case, I mean, it has been chosen that they are going to use a 25% duty cycle. So the motor will be operating at a quarter of its maximum speed, right? And then once the PWM pins are set, we need to turn on the motor, right? So now everything is all set to go. So we start the motor, right? So one pin will be high, one pin will be low, right? Whenever you are using a LED or you're like turning on something, right? We have a positive and negative pin. So one pin goes high, one pin goes low in order for the system to work, isn't it? So likewise, it goes for the motor as well. So one pin will be high, one pin will be low, right? Then once we have done that, the system starts, then we go into an infinite loop, right? This is an infinite loop. And in this particular loop, it is basically the code for the 7-segment display, right? Whatever count you have, we just need to display it on the 7-segment display, right? So this is kept into 7-segment the 7-segment display loop is kept inside the while loop because it has to be a continuous. If you don't place it into a 7-segment into a while loop, what happens is one of the LED that you are focusing on will be only on, right? Not all three will be on. So we need to keep it in a constant while loop so that all three are visibly active, right? When we are passing a 100s code or a 10s unit or just a unit part, right? So this is 100 digit, this is the 100th digit, this is the 10th digit and the 1st digit, right? So if you are passing, when you are operating the 7-segment display, one 7-segment at a time will be turned on, right? Isn't it? So if we don't keep it in a while loop, it will appear as if only one of the 7-segment display is on. So in order to realize it as if all three displays are working, we need to keep it inside a while loop. So that is why it is kept inside the while loop, right? For the code for the 7-segment display. And like I said, the enable interrupt in this particular case has been chosen to be placed inside this particular loop, right? The while loop. So basically what happens is that each time whenever the external interrupt is triggered, right? Whenever the external interrupt is triggered, we have already defined this. So the motor is on. So once this conveyor belt starts, it will trigger in. As soon as the bag of fruits passes the proximity sensor, there will be an external interrupt, right? Since the initial point, the interrupts are enabled. So there will be an external interrupt that will be triggered. So it will go into the external interrupt loop, right? This is a loop. In this loop, we are disabling all interrupts, right? We are disabling all interrupts. So that means next bag that passes will not be counted, right? At the moment. but this program will definitely count because it goes in a quick loop, right? The execution time will be quite less. So it just disables it, right? Disable all interrupt. It increases the count. It will just take a fraction of time, right? If it was really slow, then it will miss out on the number of flags as it passes, right? But this just takes a fraction of a time. It quickly counts, increase the count, and then it takes that count value and then displays it, right, inside this while loop, because this is a continuous loop. So that count value is being displayed in this loop, and as soon as that new count value that has been displayed, and it goes into this enable. The external interrupt that was disabled, it is now being enabled, right? And the other thing is that you can also take this while loop, this whole code, and you can also place it inside this external interrupt loop as well, right? So basically, you write this, you show it count plus value, and then you basically take this loop, this whole code, and place it inside this loop and enable the interrupt. So basically, this while loop will be empty, right? Just while one. That's another way of writing this particular code. But apart from this, all the codes that you have learned, right? That is the external interrupt part. You have learned about the motor and the 7-segment display. All are just pieced together, right? They are joined to create a whole. One program. There's nothing new. There's nothing complicated about it. It's just done step by step, one at a time, right? So all the programs are joined together. So we have a code for the external interrupt, we have a code for the PWM, and then we have a code for the 7-segment display. So this is something that you are going to be doing in your projects as well, right? Let's say if you're using a temperature control, if you have a project with temperature control, then you'll have a temperature sensor. You'll have a 7-segment display, you have a keypad entry. So only thing is that all the codes will be given. You just need to place it into the correct order, right? Like they have done it over here. This is a just simple project code, right? This is something that you should start practicing all this, because similar problems will be given in your final exam as well, right? And in your short test too, most probably. I'm not sure, but similar problems will be tested in your final exam. But since you are not going to have a final face-to-face paper, so it will be mostly online. So I'm not sure, it might be an assignment or something like that. Your lecturer will advise you on that, but similar problems will be tested. So do you guys have any questions regarding this? I believe all of you are waiting to take the screenshot of the solution, right? So let me check. Okay. Just hold on. Okay, the code is from here. Okay, let me save it as a PDF. So all of you can see this screen? All of you can see the code? The whole code is on this screen. Okay, great. You can take the screenshot of this, right? This is one. Right? So once you have taken this, you can just comment done, so I can move on to the next slide. Right? Next page. Okay. Okay, great. So all of you have taken this. Is there anyone left? Okay, let's move on to the next page. Right, you can see the next page. Or if you can see the next page on screen. Starts from main, it goes up till the last braces. So whole of the main part is given, right? Okay, great. So you can take the screenshot of that. In the meantime, I'll take the attendance. Okay, give me a minute. Let me just take your attendance. Okay, great. So all of you have the solutions with you, right? So you need to take this, copy these solutions down and submit it in your Dropbox, right? The Dropbox that is given there. Apart from this, if you have any other questions, you can drop me an email or Dr. Mehta, right? And we'll end this tutorial here. Okay. See you next week. I'll post the link for next week's tutorial online, right? Most probably it will be the same link, but I'll let you know which link we are using for next week's tutorial. It will be at the same time. Right? The timings won't change. So anyways, so let's end this session over here.